In this week, I'm going to continue the topic of the general linear model from the last week. In the last week, we have already shown you how to perform so-called first level GLM model analysis using SPM 12. And in this week, I'd like to give you two different sections. The first one, I would like to extend the usage of the first level in the first section. And the second section, I'd like to go into the topic of the second level. That means the group-wise analysis. Again, using SPM GLM model, but now so-called second level analysis. Okay. Again, please go to my website and download the materials and the handout for this week. Week 8, brain activation GLM model, Part 2. And also we'd like to use the same data set from the week 6. Again, we will use all the data with the preprocessed step. That means you have to have all the smoothed and bounce correct data on hand to continue this week's topic. Okay. And this is the list of the employed software today. It's actually the same software that we used in the last week. So you don't need to download any new software package right here. Just use the micro, SPM 12, and again the X-ray view, one of the very handful useful viewing program for SPM. And again, we still working on the very first part, and that means the brain activation right now. But today we are going to introduce the group-wise analysis, so-called second-level analysis. So let's start from the very first part. Again, I'd like to continue the topic about the first level. But today I'm going to show you more details about how we can set up the model construction. That means using the first level model construction right there. And again, I leave the slide 6 right here to let you again to understand what parameters we used for the fMRI imaging. And if you need, just come back to this slide and check the parameters. Okay, so now let's go back to the SPM interface right here. For the menu figure, you can see there is a button called specify first level right here. And now, in the last week, I only go through several different parameters right here and also give you a mat file that can help you to see what I set up for you. But in this week, I'd like to extend more details about this one, data and design right here. So please now go to the SPM interface right here. You can just click the specify first level button right here. Okay, and just wait a moment. Now you can see the full list. I have gone through, I think, most of the parameters in the last week, but today we'd like to see this more. Okay, this one. You can see that the original one, you didn't see the item of the condition. If you may recall that in the last week, I have told you what you should set up for the condition. For example, you need to set up onset, interval, or something else. But if you come back to the very original list of the first level model construction, you will see there is no condition item right here, because you need very first step, you need to double click on this data and design list right here. Just double click. Now you will see it will automatically add in one more item that is called subject or session right here. Normally we will use the session in this item. So you can see now for this one, if you have one session scan, that means, for example, we have one back scan right here, then you will have one session. And the condition, again, you need to double click on the conditions right here. Then you will see it will automatically add in one new condition right here. So in the next week, we will assign or specify all the one back scans, exactly 165 follows imaging to these scans input right here. And then we will specify the name to one back, and onset we will have 5 onset because we have 5 blocks within this session. And the duration would be 15 scans right there. Okay, this is what we did in the last week. But in this week, I'd like to do more. Can we actually put both one back and two back sessions data together? Can we do that? Actually, you can. The way you can do so is actually that you can add in one more session. Now, please go back to the item data and design right here. Just click on this one. You will see now you will have several options in this panel. You have the very first one, new subject or session right here. And now you can do what else? You can replicate. You can duplicate this exist subject and session. You can see there is a number 1 right here. That means the only current one is this one. That means you will duplicate all the parameters or all the setup for this session to create another new session right here. Okay, so what you should do, I would suggest if you have two very similar sessions, just like what we have, one back and two back, we have a very, very similar setup. That means we have the same 5 onset time points, and we also have the same duration. That means 15 scans. Then you don't really need to duplicate the session right now. What you need to do is actually you need to key in one of the session, then copy this to create a new one. So what I'm going to do now is I will first off key in the one back right here, the name one back, and the onset, as we said before, you will see this 1 to 165. Okay, so we have 5 specific time point for the task onset or one back onset, and durations should be 15. So the duration should be 15. 15 right here. Okay, so this is actually the setup for the one back. But again, I would say that even for the two back session, we will have pretty similar or exactly the same setup for that. So once you finish the parameter setup, now you can go back to the data and design right here. Now just click replicate the subject session. Just one click, and you will see, just come down, scroll down, you will see there is another session. This is the first session right here, and now you have another session right here. Okay, so now what you are going to do is you try to pull both one back and two back data set within one GLM model. Okay, so now for the first one, it should be the one back, that's right. But for the second one, I'd like to rename, the name should be two back. Okay, this is the way we discriminate these two different sessions right there. Otherwise, all the parameters are the same. Okay, perfect. So this is what you have on hand right now. Okay, and as you can see right here, that we mentioned we can also input the motion parameters. That means the 6 color motion parameter that we acquired from the realignment step. We will input the parameters to the multiple regressors right here, right? And you can see that for each session, you will have one multiple regressors input right here. Okay, so for another session, again, you will have another one multiple regressors. If you may recall that we actually performed the realignment for one back and two back respectively, or separately. So we will have 2 different motion parameters right there. Okay? Okay, let's come back to here. So now as you can see, when we try to acquire the FMR data, we actually deliver 2 different sessions, one for one back. As you may recall that we actually instruct our participant through the voice. We just told him that we are going to start the one back session. So please, if you see the number showing on the screen is identical to the previous one, then please click the button. And for the two back session, after the one back session, we stop the scan, and again we just told participant that we are going to start the two back session. Now, if you see the the numbers on the screen is identical to the 2 previous numbers, then just click the button. Okay, so it's actually 2 separate sessions when we acquire the fMRI data right here. But you can see that all the parameters are exactly the same. Okay, and now go back to this one. Okay, And after the setup for the subject and session and condition, now we should go back to this one. Remember that we should set up the micro time resolution to the slice number, so it should be 40. And the micro time onset should be the reference slice, and it would be 1, the first slice. Okay. And again, this 1 unit for scan, we select the scans. And the scan interval, that means the TR, repetition time, it should be 2 seconds. Okay, right here. Okay, so that we should do right here. So now you can see we need to specify 5 different input right here. The first one should be the directory you'd like to output the spm.met file. And then the second input should be the scans for the 1 back session. So again, you will select 165 preprocessed images to this input. And then you will go to multiple regressors right here. This should be the 6 column parameters for 1 back session. Okay, realignment 6 column parameters for the 1 back session. And then you will come to this one. This is a second session, so this should be the 165 files for the 2 back images. Of course, the preprocessed image right there. And then go to the multiple regressors. Now this one should specifically select the 6 column parameters for the 2 back session. Okay. So this is all 5 inputs you should select. So again, if you cannot follow my path, please, you can find out there is a mat file in the downloaded folder. Within today's folder, FMI analysis 08 underlying materials, there is a so-called unback underlying for model.met. You can simply open the page figure and just load this mat file. Then you will have the exact list that I displayed on the screen right here. Okay. So now what you are going to do is now you need to be very carefully select the 5 input right there. The first one, directory. And again, in the last week, we normally pick up 1 back or 2 back folder right there. But now we try to pull both into one new data set. So now I'm not going to select each of them. What I'm going to do is I'd like to create, I should go back to the 6. Week 6, yeah, this one. And within the process folder, I'd like to create a new folder. Now I can just call it unback or something, because this one is the one that I need to pull both of them within. Okay, so now I can go back to the SPM. Just go back. It didn't update the list, so let me open it again. Well, this is actually on the desktop, so I should go to this one. Just wait a moment, I should update my current folder. Okay, to this one. It will make it easier to select the file. Okay, this one. So now what I'm going to select to specify the directory for the SPM output is this one, unback. Okay. And then come to the second one. As I mentioned, we should select the 1 back data set right here. Of course, we will select the data with BIOS corrected and smooth, and again the normalized process. So now we have select all. We have all 165 files right here. Okay. And then for the multiple regressors, now you need to pick exact one for 1 back session. This one. Again, you can find out the RP underline, this one. Okay, so you have finished the files specified for the 1 back session. Okay, now go to the 2 back session right here. Go to the 2 back folder. Again, you should find out the file with M, S, and W prefix. That means BIOS field correction, smooth, and normalized. Select all, 165. Right there. And the multiple regressors. Okay. Now go to the 2 back, select the RP underline files right there. Okay. Again, once you finish all the file input or file specification, now you can press the run button right there. Okay, so I'm going to press a button, and I'm going to stop right here and to make sure that all of you know how to do this. Okay, so let's continue. So after you finish the model construction, you should see the figure displaying on the SPM. Would have this kind of a so-called design matrix right here. As you can see right here, actually we have two sections right here. So the upper left corner is actually for the section of the one back, and the lower corner is actually for the section of two back right here. Okay, so you can see there are two different sections pulled together. Okay. And you can see on the first column right here is the block design. So you can see there are five white bands right here. That means we have 5 task blocks for one back right here. 1, 2, 3, 4, 5. And followed by the six so-called the motion parameters right here. So the first 3 for the 3-axis translation, and the last 3 for the 3 different rotations. And again, you can have the two back right here. So you can see for the first 165 image files right here is totally for the one back section. So you can see there is nothing for the two back, all gray out. That means no information for the two back. But for the start from the 166 files to the 200 and I think 230, okay, 30 files right here, that would be the two back section right here. So again, you can see one back plays no role right here, but two back plays main role right here. Okay, and the final two columns are the constant regressor right here. It will automatically aided by the SPM. So you will give the flexibility that the major signal can be shifted. That means the average or the mean value of the major signal can be adjusted to match the study design right here, or experimental design right here. Okay, so you can see this is the way that how we pull different sections right here. So the application of this combination of different sections may be you can compare different sections with different conditions, or you may have the ability to combine different sections but with the same condition. For example, you'd like to deliver one back with, for example, 20 blocks, but the 20 blocks for one section is too long, too tedious for the participant. So what you're going to do is you separate 20 blocks into 4 different sections, and then when you do the GLM model, you will pull all of them together using this kind of approach. Okay. After the model specification, what you are going to do is actually same with what we did in the last week. You need to specify, then estimate, and finally review the result. So the next step, please click the estimate button right there. So now let me click. Once you finish the model construction, now this one, just click the estimate button. Again, you need to select the SPM.met file. Now just go to the unback folder right here. That is the SPM.met file exported. Okay, right here, and click Run Batch. And now the MATLAB will start to estimate this model. It just takes, I think, 30 seconds. Then it will finish. Just wait a moment. And after that, after the estimation is done, then you will have the chance to review the results. Okay. Once the estimation is done, what you can do is you can review the result, right? Just click the results button. And then you will see the contrast manager again. But now you can see you may have the chance to compare the two back with the one back right now if you pull both sections together. For example, I can construct a contrast called two back minus one back. What we are going to do is I will select the parameter value to be -1 for the first column, because I want two back minus first back, right? So this one would be -1. For the second third, fourth, fifth, and sixth column, I will input 0 because I have no interest for the motion parameters right here. But for the eighth column right here is actually the column for 2 back. I will key in the value of 1. That means I will use this one as the positive event to minus this first 1 back event. So it will give you the contrast, so-called 2 back minus 1 back contrast right there. Okay, let me see if my estimation is done. Done. Okay, so what I'm going to do now is just click the result button right here. Okay, so you need to again specify the SPM.mat file right here. Then you will see the contrast manager. So again, now please click the button define new contrast on the left and the lower corner right here. Okay. So again, you need to key in the name. So I key in 2 back minus 1 back right here. Okay, this is just a name. Anything you'd like to input, it's okay. But the contrast right here is I would put for the first value for minus 1, then followed by the 6, 0. That means I don't want to see any effects from the motion parameters. Then put 1 for the 8th column and followed by 0. Again, you don't need to really finish all the parameters. If you just stop in one of the columns, it will automatically add in 0 to ensure that the vector length is matched to the column number right here. Okay, you just click submit. Then you can see this is the way you to observe so-called the 2 back minus 1 back. If you want to see the reverse effect, that means you want to see is there any brain region that is activate higher or stronger in 1 back condition than 2 back. Then what you need to do is to put 1 for the first column, but minus 1 for the S column. So right here it will be in this way. That means you are going to observe the effect that stronger activation in 2 back compared to the 1 back compared to the 2 back. But normally we would be more interested in 2 back minus 1 back because we assume that during the 2 back session it is a more difficult one. That means you give more workload to your brain. So supposedly it should activate stronger activation or something in your brain compared to the first session. That means the 1 back session. Okay. So what I'm going to do is just use this one, 2 back minus 1 back. Okay. This should be the correct one. If you finish this one, just click OK, and you will have this one. Okay. Again, if you are going to answer another question, is there any common or shared brain activation no matter 1 back or 2 back is delivered? Then what you are going to do, you need to design a new contrast. That will be, maybe you can key in 1 and maybe 2 back. For example, right here, what you're going to do is you put 1 for first column, followed by 6, 0 again, then another 1 for the S column right here. So now you can see first column and the S column right now is actually add with each other. That means I don't care 1 back or 2 back condition. I want to see the overall condition, or I don't want to see the difference from the workload. I just want to see if the subject or the participant is doing some tasks related to the working memory. What kind of a brain region will be activated? So you can see if you actually have the situation that I mentioned before, you really want to get the 10 blocks for 1 back, but you don't want to give such long image acquisition for participant. Then you can actually separate it into 2 different sections. And the comeback here, you put 2, 1 for these 2 different unback section right here. That means you can see the overall effects for 2 different things right here. Okay, so you have now 2 different contrasts right here. Okay, so let us start from the first one. Oh, another way is you can also do the pretty similar things that you did in the last week. If I only want to see the 1 back effect, what can you do? Actually, you can do this one. Just give the 1 to the first column, and the others are 0. This is a way you can see the 1 back. You have no contrast between 2 back and 1 back, but only for the 1 back right here. This is the way. If I want to see 2 back, what I'm going to do is give only one value to the edge column. Let's see this right here. You need to input 7 zeros. Yeah, right here. This is the way you show the 2 back effect right here. So now you can compare 2 back, 1 minus 1, edge minus the first column. 1 and 2, you give both 1 to 1 and edge column right here. 1 back, only first column, and 2 back, only edge column right here. So there are several different ways to decide its contrast. Depends on what is the question you are going to ask. Okay. So let's come back to the first one. I'd like to see, is there any brain region would have stronger activation when the subject is doing 2 back compared to the 1 back session? Okay. So I select the very first one. Okay. Click down. Now just do the very same thing. I think in this way I can still use the FWE. That means restrict the multiple comparison correction. And again, I use a 0.05 p-value. And the 30 voxels as the threshold for the cluster. Okay, so now you can see, actually now it's only 2 regions. The first one is actually the right-hand side. Right, dorsal lateral prefrontal cortex would show higher activation in the second, in a 2 back condition compared to the 1 back. And another one is actually, I think this one is in the motor area right there. So I think this is another one. Yeah, this one should be the motor area for the specifically for the hand motor area right there. Okay, so this is the way you can do. If you'd like to change the different contrast, you can either click the result button again and specify the SPM file, and then pick this one. Okay, you can do so, and again use the 0.05 and 30. Now you can see this is actually the region that activate for both 1 back and 2 back session. If you would like to change the contrast, you can not only use this way, there is an easier way to do so. You can see there is a contrast toolbar under the menu window, under the process window right here. Okay, now you can see there is an option called change contrast. You can come to here. Now you can easily switch different contrast using this way. You can see it's much more easier. This is the difference. This is the combination. Okay. So this is a way you can switch from different contrasts you can do. And again, for the result right here, you can go back to the unback folder. Now you may find out that now you have four different SPM T means T contrast. Okay. Underline, now you have 4 different nifty files right here. And each one represents the result for the specified contrast. So the 0001 means the result for the first contrast. You need to memorize what is the first contrast. That is the 2 back minus 1 back. Okay? And then 0002 nifty file means the result map for the 1 and 2 back. Okay, so you can see right here there are 4 different. So what you are going to do is you can exactly use the X-ray view. If you may recall, X-ray view is pretty handful, useful package or toolbox for reviewing the result from the SPM. So now what you can do is, if I'd like to display the result, you can open the imaging, and now I would select first one. Okay, I want to see the result that using the 2 back minus 1 back as the contrast with this one. So not only you can see pretty similar map, or you can just only display the positive one. Normally we are simply interested in this one. And you can see now the p-value is actually looser compared to the what we used in SPM, because in SPM we use FWE, family-wise error correction. Okay, but right now we only set up the p-value using the 0.001 without any correction for multiple comparison. If you want to see the exact result, that is displayed within the SPM, you can key in 0.05 right here for the FWE. The result would be pretty similar to the SPM. Okay, and as I mentioned that sometimes if you use FWE and there is no significant region that you can report, you can use the looser way. That means the FDR, okay, false discovery rate correction. This is again a way to correct the multiple comparison error, but not that restricted as the FWE did. So what you can do is again put 0.05 right here. You can see the p-value is much more higher compared to the FWE. This is the corrected p-value right here. For this one, again, it's around, I think, well, it's pretty small. You can see it's very, very small. But for this one, it's around 0.0009. Okay. But normally, I think the most original way is you just directly use the 0.05. But however, this way is just too loose that so many different regions will show so-called the significant difference between 2 back and 1 back. At least you should use this one, FDR. This is the very least one you should use. Okay, so you can see this one. Okay, and again, with the X-ray view now, you can just display using the slice view right here. So I just roll down, so you can see there is a very small region right here. But again, it still has a cluster larger than 30 voxels, so it will be recognized as a region with the significant difference between 2 back and 1 back. So for this participant, this is the key region that is showing the workload is increased during this kind of fMRIzation. And again, you can use the render field right here. Just click double times. Okay, so you can see there is one region right here. Right hemisphere, right dorsolateral prefrontal cortex right here. Okay. Again, you can use the just the tracer right here. You can identify this region. You can see there is AL template showing that this is actually located in the middle frontal gyrus. That is so-called dorsolateral prefrontal cortex. Okay, so I will take a 5-minute break right here. Please ensure that you can actually go through different contrasts. So you can see in the PowerPoint right here, in the slides right here, we only set out 2 different contrasts. But as I displayed on the screen previously, you can actually design several different contrasts depending on what is your question. Okay.